The theory of plate tectonics. The theory of plate tectonics explains the formation and the Earth's features. It discusses three different kinds of plate boundaries and the result of each, such as landforms. Now I'm going to explain the theory of plate tectonics. The Earth is formed by three main layers: the core, the mantle, and the crust. This is a diagram which explains the Earth's structure and as a brief information about the crust, mantle, and the core. The crust is divided into continental crust and the oceanic crust. It is mostly made out of rocks and it is the thinnest layer of the Earth. It is about 10 to 70 kilometers thick. The oceanic crust is formed by more dense rock and the continental crust is formed by less dense rock. After the crust there is also another thin layer called the lithosphere. It is located between the crust and the mantle. The asthenosphere is located in the upper part of the mantle and is where the convection current also takes place. The mantle has the biggest volume of the layers of the Earth. The rocks are plastic-like and are in between solid and liquid. It is also where the convection current takes place. The rocks are more dense than the rocks in the crust because as we go deeper into the Earth, it gains more pressure and it's hotter. The core is divided into the inner core and the outer core. It is the deepest part of the Earth's layer and has the biggest mass. The core is made out of metal elements because the inner core mostly has solid metal and the outer core is liquid-like metal. The core also acts like a fire in a frying pan, so it also has a role for causing convection current in the mantle. It is important to know the Earth's structure when we are discussing plate tectonics because it explains the movement of plates. A scientist named Alfred Wegener made the hypothesis called the continental drift. This hypothesis was a guess that the plates were once one big landmass and it is still moving today. He had several pieces of evidence that backed up his idea. These included glacier deposits, mineral deposits, and different kinds of rock type, mountain ranges, and fossils. These evidence could support his idea because some rock types that are found in a specific area were found in another area which was far apart from each other. Another evidence would be fossils of the creatures from the past was found in two areas and were far away from each other. And when you use this evidence and put it into where they fit, it made Pangea and was just like a large puzzle. He could explain this hypothesis, except he couldn't explain how the continents moved, so some people didn't believe him. This is a Pangea I made by myself and was my guess at how it would look when it was a one big landmass. This Pangea also explains the evidence that I used to put the pieces together. This is an animation I made which explains how the continental drift happened. You can see the movement of the plates from this animation. This is how the Earth looked 200 million years ago. And this is how the Earth looked 135 million years ago. This is how it looked 65 million years ago. And this is how it looks today. The plates move by convection current in the mantle. This is the reason why Alfred couldn't explain how the plates moved. The plates are driven by convection current that is under the crust and acts the same as a hot boiling water. The core is like the heat source in the asthenosphere and the mantle is like the atoms, and the density of the rock changes so it moves in a convection current. This is happening by rocks, so this happens really slowly. There are several convection currents happening just rather than one, so as these convection currents happen, it also is part of making the three plate boundaries, because convection current can move in different directions, so it causes the Pangea to move apart. Seafloor spreading. Seafloor spreading is when the new magma forms a new seafloor which rises up to the surface and pushes the old seafloors apart. This happens because new magma is always forming in the mantle. Evidence that this is happening is the observation with magma rock ages. So when the rocks are further apart, it's older. When it is in the center, it's the newest. And magnetic reversal. This is also a support of Alfred's hypothesis that the new seafloors are kept on being made. When seafloor spreading occurs, it forms mid-ocean ridges. This animation explains how the seafloor spreading works and how the seafloors are pushed apart. You can see the blue seafloor is pushed apart and the gray seafloor is pushed into the center. And when the green seafloor comes up, the gray seafloor is divided into two, and then the blue seafloor is also pushed apart and the other gray parts are also moved. As the green seafloor is divided again by the new seafloor which is coming up is the gray seafloor. So when the gray seafloor forms, the red seafloor is the new seafloor and it pushes the gray seafloors apart. So this is animation which explains the movement of seafloor spreading and how seafloor spreading occurs. The three types of boundary are convergent, divergent, and transform boundary. All of these plates are formed because convection current in the mantle is always happening. These plate boundaries can form mountain ranges, trenches, earthquakes, faults, rift valleys, mid-ocean ridges, and a lot of other possibilities. Convergent boundary is when two plates collide into each other. When this happens, subduction happens. When two plates collide, the denser plate is forced down into the mantle. When it is in the mantle, the magma that has nowhere to get out, it causes volcanoes to erupt. Landforms made by these boundaries are trenches, which are made from subduction, mountain ranges, and etc. When convergent boundary happens on continental crust to oceanic crust, it forms a trench. Oceanic to oceanic makes a deep ocean trench, and it is also a result of volcano after subduction happening. Continental to continental form mountain ranges. It works like when you have two papers getting pushed into each other. Divergent boundary is when two plates move apart from each other. So when they separate from each other, mid-ocean ridges can form underwater. Divergent boundaries also form rift valleys. Rift valleys are formed when continents are moved apart and it gets bigger and bigger, and when it reaches the shoreline, the ocean water flows into the rift valley. Transform boundary is when two plates slide past each other or goes in the same direction but it is sliding past. The plates can move the same direction, but in different speeds. This boundary can cause serious earthquakes and form faults. Faults and earthquakes are formed because when two plates slide past each other, they are not smooth, so it causes the plates to go up and down. This is a map of the world which are labeled where the three types of boundaries are happening. There are three main heat transfers. They are conduction, convection, and radiation. Conduction is a heat transfer by direct contact from object to object. They are transferred by a hotter object to a cooler object. Conductors are objects that conduct heat better than others, such as metal elements. Insulators are objects that don't conduct heat easily, such as liquid or gas. Radiation is heat transfer by traveling in space by electromagnetic waves, such as heaters and the sun. Convection is when a fluid causes change in their density. Convection currents work like a cycle. The atoms at the bottom gain heat and energy from the heat source, so they move around and take more space. So the density becomes less and less dense objects float, so they will rise up. When it is on the top, it doesn't get as much as heat, so the atoms don't move as much, so they become compact. So they will get denser and more dense objects sink. So this is how the convection current works. Convection is also happening in the mantle. It works just the same. The core is like the heat source in the mantle. The rock elements are like the atoms. There are several convection currents happening at the same time, which occurs plate boundaries because the convection current could be heading to different directions. This is a diagram I made which explains how the radiation, conduction, and convection works, and some pictures that explain the three types of heat transfers. This is the end of my photo story, and thank you for listening.